Hi, this is Davi Chavez from FRC Team 714.
This is Chris Marrera, 714 Robotics.
This is Dirt Cheap Robot Localization. Our name was actually inspired by Team 971's presentation on smoking fast April tag localization. FRC robots compute their X and Y coordinates by counting wheel rotations. This is known as odometry. This is so they can drive to their scoring locations exactly. The problem with this is that when robots push against a wall slash reef, the wheels slip. This messes up the odometry and messes up their X and Y coordinates so they don't know where they are on the map. Good news, on the 2025 field, almost always your robot sees 2 or more April tags on the field. It could know its X and Y coordinates from anywhere on the map because there's multiple April tags around the entire field. Today's slideshow is going to teach you guys how to make a simple localization control system by putting 4 cheap cameras on a robot to make sure your odometry doesn't slip. Part 1, the idea. This is the typical FRC field.
Mr. Ford.
North is always the direction of the red alliance on the field. No matter what alliance you're on, it's always going to be red. And now I want you guys to imagine that a robot is seeing tag 4 at plus 25 degrees north and tag 1 at minus 20 degrees north. Now my question to you is, where is the robot located on the field? It must be in the area where the two lines intersect. From the angle of the robot visualizing the April tags, it can compute its X and Y coordinates.
Part 2, the math. Wait, but how did the robot know the angle between each visible tag and north? Example, robot is seeing tag 4 in its camera 1. It's all geometry. Next slide. Step 1, which direction angles does the robot already know from sensors? Direction of camera 1 from robot gyro, direction of tag 4 and camera from photon vision, and north. It's all geometry.
Myers videos look fire.
Step 2. Imagine gyro says camera direction is plus 45 degrees, left or north. Say gyro says that camera 1 is facing plus 45 degrees left of north. Plus 45 degrees north. Step 3. Imagine that photon vision says the tag is 20 degrees right of camera nose. Tag 4 is plus 20 degrees right of camera nose, says photon vision. Question. Can you calculate how many degrees between tag 4 and north? Gyro says that camera 1 is facing plus 45 degrees left of north. That's right, subtract them. Plus 45 degrees plus 20, 45 minus 20 equals 25 degrees. The formula to compute direction of every tag, not very complex, right? Tag direction to north, camera, direction from robot gyro, minus tag direction, yaw from photon vision. We asked our mentors to do the last step. Write the code for converting the line to tag angles to the intersection XY coordinates because it involves linear algebra.
Part 3, the budget. This is the name of our slideshow. It's actually just so dirt cheap. It's $318 for 4 cameras, 2 Raspberry Pis, 2 cases, and a power adapter. Now, the reason why we call this a dirt cheap presentation is that the limelight cameras that we usually use for detecting April tags cost $400 and they are currently sold out. So we can't afford to buy them above retail price because that would be way too expensive. And right now, we're showing you guys how to make a almost 360 degree vision of a robot with 4 cameras for under the price of one limelight camera. Photon Vision, the website explains pretty much everything about global shutter and cameras with the highest FPS and why they're better for detecting April tags. You can just go see it at the link below. Part 4, the hardware setup. Now I'm gonna voice over some clips of me building the localizer at school. This is the localizer we previously built in our last video. We taped 2 cameras, the front and right camera onto it.
it is connected to a Wi-Fi switch and not the actual robot because we're going to show you a demo of how the localizer actually functions. The front camera is an Arducam, which can see 70 degrees, and the right camera is a Alp camera that can see 100 degrees. So this is our setup for the localizer demonstration right here. As you can see, the Wi-Fi switch is connected to a power bank that's also powering the localizer. In front of it, we have to demonstrate detecting it, and on the right, there's also another April tag to demonstrate detecting it. Now I'm going to show you guys how to set up the localizer and the cameras to test out if they actually do work. First off, you want to go to connect to the Wi-Fi switch that the localizer is connected to. I've named it Localizer Go 714. Just connect to it. Okay, now that this is connected, you're gonna want to go to the camera URL, which is just we've already named it front right, but usually it'll be photon vision dot local colon 5800. Now that we're on the photon vision page, you can see that we've already labeled each camera uh, their set direction, Arducam front, and Alp right. These names do correspond for what you put in the code, so make sure they're the same names that are in your code for the program, for the localizer. And as you can see, the right camera is detecting April tag 3, and if we moved on to the front camera, you can see it's detecting April tag 4. Okay. Now you guys want to go to the 714 Robotics YouTube page where my mentor posted a super simple photon vision video and how to set up photon vision on your guys' localizers. Yeah, but primarily the main focus of us going here in this
Now we'll need a network
the
cable.
code for the localizer
Plug
is
it
actually in
into
the
here,
description.
like so.
Uh,
This will plug into the robot.
Now it should take you to the GitHub page where all the code is, and as you can see, it shows all of the setups like arm, elevator, driving mechanisms. But the thing we want to focus on is the localizer. Now we can just this is just a set example of the localizer code that we can copy and paste into our Python. Now we're going to want to set up this code and make sure that all your cameras are correctly labeled as what you put them in the Photon Vision app, and make sure they're on the right degrees. Like front should be direction 0 and right should be negative 90 because that's how it is in the coding. Now we're going to want to test this in sim to see if the localizer code is actually working. First, we're going to want to run the localizer on this laptop as a simulation and not on the actual robot. And the way to do that is we actually need the IP address of this computer or whatever computer you guys are using. And to do that, we just go into the command prompt and we type in ipconfig and should say right here, this 10.7.4.2. We'll just take that and then we'll go back to our Photon client and instead of putting your team name or team number, you actually want to set it up as your IP address on the computer. As you can see, we already set it up, but once you have that set up, you want to go onto your PyCharm and run it on .sim. Now, as you can see, everything is working fine. It doesn't, if you have code for multiple cameras, but you only have two cameras attached, it should work fine. They just won't give you any readings. For the sake of this example, we made a very simple autonomous code, which just sets the X and Y coordinates of the robot on 12 in Y. You can see at the top here, it explains all of it. This is just so it's like in between the April tags 3 and 4. Yeah, so basically we just want to make sure that our robot is approximately here in this position on the field map. And then as you can see on Elastic, it's also approximately in the same area. If you're wondering what Elastic is, it's a dashboard for FRC robotics. If you want a more detailed explanation on it, you can go to video 13 on our team channel. Now to run the code in the simulation, we just press run. Now we're going to want to press autonomous, and we're going to want to go to the dashboard. And as you can see, the X and Y coordinates are 12 and 6, like how I showed previously on the code. Now when we turn on the localizer, you can see that the cameras are both detecting April tag 4 and April tag 3, and it's moving the demo, the localizer, to where they should be, where the two lines intersect. Now, if we were to move where the cameras are actually on, you can see that the localizer also moves as well. You try to make sure that both cameras are seeing one of the April tags so you can figure out where it is. Now, this is an example of what happens when the localizer sees three tags. Right now on the right camera, we can see tag 2, while on the front camera, we can see tag 3 and 4. Now, if we run the code in the simulation, we can see that it will actually place itself at the original code where it is. And now if we turn on the localizer, you can see that it is trying to figure out where it is on the field when it sees all three tags. Now it seems a little like wonky and warped, but that's because the code that we have is set up so the distance of the April tags is the exact distance they are from each other on the field. And since this is just a demonstration, they aren't the exact distance they are from each other on the field. So it'll end up looking how it is now, which is a little wonky. Yeah.